somewhere where I went, okay, if I could bring this in-house, I could charge.
By using a straight line angle, I can take 3 measurements around.
At the tips now.
So, the kind of person that really likes to
Live from Studio 3 in beautiful Naperville, Illinois, Spanesi Interactive Week continues with welding and joining for OEM repairs. Allow me to introduce you to your host, COO of Spanesi Americas, Mr. Tim Morgan.
Good morning, everyone. I hope everybody's been enjoying this week as much as we have. It has been a pretty exciting week to be able to do this, be able to bring this out to the industry, and it's something that's going to continue. We already had a couple of meetings about what's next, where do we go next, what do we do? So pretty excited today to be working back again with the technical group out there, and we're going to go live to Studio 1 with Jeremy Holloway, our Director of Technical Training, and Brett Runyon, our Sales and Technical Specialist. How you guys doing this morning?
It's better when you can hear the microphone. That's all I'm going to say is audio is a key ingredient to this experience. So let's ask them again. How are we doing out there, guys?
We're doing great.
doing great.
Good.
There we go.
Good. So what do you got for us this morning? I see you got a MIG welder set up there. You got a spot welder set up.
Yep. So what we're going to do today is we're going to show you some of the features of our Q5.2 inverter MIG welder. And then we're going to talk about the 14500 squeeze type resistant spot welder. So being as this is OEM welding and joining, if you don't know, you will shortly, if you're running a body shop or a technician, that OEMs are requiring different types of machines, different types of filler wires, different types of gases. They all have a specific way that they want you to join the car back together in a collision repair. And the reason they do that is because they want you to reproduce the original manufacturing strength and joining method. And what they're doing there is they're doing their absolute best to retain that crash characteristic or that strength when we have that second collision. So we're making it safe when it goes back on the road.
How important do you think it is that we look at the OEM requirements or specifications before we start welding on something, Jeremy?
I would say that I would not perform any repair on any vehicle until I read the repair procedure, because they are all just a little bit different, and there is no way I would go into a repair blind and assume that I know. Even if you made a repair, say you put the same rear body panel in last week and here you are doing it again, I'd read it again, because they do update them on the daily.
Constantly.
So yeah, I would definitely read the repair, make sure that you're going to use the correct joining method, whether it's welders, whether it's glue and rivets, what have you. You want to make sure you have all of those correct tooling, equipment, consumables on hand, ready to go.
Well, and that's a key point there. When you mention, even if you did it last week, it may have changed. Check it again, because that is very true. Procedures do change as the repairs evolve. Sometimes they come up with an easier way to do it, or they find that they change that, and we've seen that in all manufactured products. Really, you can't do anything without the procedures. And even in the presentation we did yesterday with Ian, he said he had a RAV4 in his facility. And by the time they got done pulling all the procedures, they had over 1,000 pages for one repair.
Wow.
Right. So first thing we're going to do is I'm going to run you through some of the basics here on this Q5.2 inverter MIG welder. It is a fully synergic welder, which means that when you adjust the metal thickness, it's going to adjust the current, the wire speed, going to adjust all that. That's just what synergic means, just multiple parameters at once. So what this is designed to do is make it very easy for you to pick up the trigger and go. And I'll explain what that means. So the way this welder works is you pick up the trigger, you click it, click the button on the trigger, and it actually changes the program on the face of the welder to that specific material type. So since we're talking about material types, I'll show you the inside of the case here. It actually, let's move it a little bit better so you can see.
There you go.
So we actually ship this welder with 2 rolls of aluminum wire, 5356 and 4043 at 1 millimeter. We ship with a roll of silicon bronze, which is 0.9 millimeter, and then we ship with a roll of steel wire, ER70S-6, which is 0.8 millimeters. So you can see that this is well equipped for welding multiple material types. And also, you actually have a chart inside of the case here that walks you through all of the programs when you're selecting the material type on the face of the welder. So it's super simple. You just open the case, you select the correct material types, diameter, shielding gas, and you are ready to go. And what's nice, once you make those adjustments, it stays there. It doesn't change unless you change it yourself. So that's what's so nice about this machine is it's designed to, once you have the settings done, you pick up the trigger and you click and go. So say you want to move from steel to silicon bronze. You pick up the trigger, click the trigger, and it actually has not only a function to change the program automatically when you click the trigger, but it also has an internal valve that changes the shielding gas over, because we know that with silicon bronze, you weld with 100% argon, steel welding, 75-25 argon, carbon dioxide. So walk through the face a little bit here. I'll tell you what we have. So here, we're displaying the material thickness. So 0.8 millimeters, we're gonna weld some steel to start out. So, and then we can cycle through viewing by amperage and wire speed. The other side, we have arc length, the voltage, and inductance. Those are very fine adjustments.
Can you explain the arc length to me?
Arc length is how far away from the surface that the wire actually burns. So that adjustment, what it can do for you is it actually, if you're further away, it actually makes a wider cone of molten material coming out of the end of the wire and actually produces a wider, flatter bead. So say you're making an aluminum weld and it actually is a little bit narrow, a little bit too hot, you can kick your arc length up a little bit and it'll distribute that current and that heat, and it'll give you a flatter bead and maybe not melt through the backside quite as much. The other adjustment we have here is voltage and electrical inductance. Those are very fine adjustments that, because you have the synergic welder, you don't always have to make adjustments, but you do have the ability to. Down here on the bottom left, we actually have MIG mode and job numbers. Job numbers would be if you had a particular setting that you wanted to save forever. Say you're running a specific bead on the same car over and over and over, and you'd never wanted that setting to change. You could save that in here. There are some manufacturers that do have job numbers in their procedures, so that could be done with this machine. Then the program button down here, if you click the program button, you can see here that we have pulse, we have double pulse, and then we actually have manual or MIG mode. So there's 4 different modes.
No, I noticed when we were in that, our program number never changed from pulse, double pulse, or MIG.
Right. So it's very easy if you wanted to go from pulse to MIG, which is actually a pretty common move when you're welding silicon bronze, to go from MIG mode to pulse. MIG mode would be if you were welding like a sectioning joint, or then you, with silicon bronze, then if you went to maybe welding the slot welds on the inner B-pillar on maybe a Honda high strength steel, you would move to pulse or double pulse. So you can make that change pretty easily here. So the other parameter here is 2-step trigger, 4-step trigger, crater fill, and spot stitch mode. So you can make adjustments there. So first thing we're going to do here is we're actually going to make some steel welds. So Brett's going to grab the steel MIG gun, which is the black one, number 1. Click the trigger. And then we're going to see that it's on MIG program 51. Where we got 51 is right here on the inside of the chart. So right inside the case here, you can see that we were on MIG mode. So here we are, 0.8 millimeters. That's within range of those metal coupons, and we are ready to make a test weld.
All right.
Cover.
Looks like that could be just a little hotter.
Yeah, so Brett made a test weld. He let me know that he's just a little bit too cold. So what we're going to do is we'll kick this material thickness up to 0.9. See how that changes the weld.
Cover.
Show them what you got there. You can definitely see the difference between the two welds. Just really with one click of a knob, we went from too cold to sufficient heat for making that steel MIG weld.
We got the good penetration on the back.
Yeah, that was really nice adjustment there.
Yep.
1/10 of a millimeter adjustment. We went from extremely cold to proper penetration. And since we're talking about making test welds, I would always recommend that take some similar material to the vehicle that you're going to be applying welds to, whether it's MIG welding, whether it's spot welding, and you need to make some test welds, tear them out, because just keep in mind, when you apply those welds to that vehicle, it's going on the road. So I don't know how you feel about it, Brett, but I know I would definitely want to be sure that that weld is going to tear out before I apply one to the vehicle and then put it back on the road. Someone's wife, someone's kid is in that vehicle. So,
well, and you also look at you should be doing that with MIG welding. You should be doing that with spot welding. And I know some shops, they actually keep those, they'll mark those test welds by the RO, and they store them so that they can prove that, they did have the welder tuned in correctly. If you're sectioning a panel, you have another part of that panel left over that you can be able to use, or you can take the old panel that you removed from the vehicle and use those to be able to make your test welds.
Right. And you can get paid for that, right? That's not a free operation. Making test welds, making that vehicle safe is something you can put on your estimate for sure.
So you can never document too much.
And that's a great point. And for more of those types of items, I'm just going to put a plug in here right now. Danny Grinenberg Forum, DEG is going to be here to talk about that a little bit later.
All right. So we made a test weld with a steel the steel wire, and we made the adjustment, and we determined that the settings are good. We can move on. So what we're going to do is we're going to move on to silicon bronze. So talk about silicon bronze a little bit. There are some manufacturers that are requiring it on inner structure. The reason they're doing it is because it's a reduction of heat input into that part. Some of the high strength steels, you can actually damage them by introducing too much heat. So silicon bronze welding, actually, let me correct myself. It's not actually welding, it's a fusing process. So it's almost like adhering that wire to the surface. But what I want you to know about that is it's right around 900 to 1,000 degrees colder than steel welding. And that's why it is recommended for, GM's recommending welding or silicon bronze application on fender rails to A-pillar. Honda is recommending it on inner B pillars. Volkswagen's using it in various repair procedures. So, but that's not the only use for it. Because it is 900 to 1,000 degrees colder, think about the possibilities. If you have to weld a tab on, when you weld a tab on with steel, where does it always tear? It always tears on the panel around the tab because you've actually introduced all that heat into the panel. If you weld with the silicon bronze by welding a tab onto the vehicle, you're introducing that much less heat into the panel, and you can make a pull, and the chances of tearing it is significantly less. I've welded all kinds of things. I've welded tears. Believe it or not, I've welded bullet holes in some doors in some of the areas that I've worked. And it's just, I actually repaired a dent from a deer antler hitting a car. All kinds of things with silicon bronze, because not only do you're introducing so much less heat into the panel, it grinds easy. You can grind it with 80 grit. You're not removing all that material around it.
It grinds down like butter. It's really nice.
I have sectioned quarter panels with silicon bronze to the point where I finished with a coat of glaze, no body filler, just a skim coat of glaze. So this really nice. And again, you only want to use it where the manufacturer tells you to. Don't start welding all of your quarter panels on with silicon bronze unless you have a procedure in hand that says it's okay to do so. So enough about all the ins and outs about silicon bronze. We're going to let Brett here. He's going to make some silicon bronze welds. So, and he's doing this in pulse mode. So we can actually demonstrate, we'll tell you what it sounds like and looks like differently when you go from MIG mode to pulse. The first one he's going to do is pulse. So we're at 0.8 millimeters. And I'm going to kick it up to 0.9 because we found that out in the last test. Cover.
Thought I was doing better than that. I think I'll try another one.
You do another one?
Yep.
All right. You need to increase the heat, leave it alone?
I think we can leave it alone.
All right. Nice job, Brett.
The first one was all operator error.
And that happens, and that's why we're doing a test weld.
You only have a couple hundred people watching you, so don't worry.
Well, I'm not going to get hired as a welder after that other one.
Well, we know today in the body shop, a lot of people are grinders more than they're welders.
Right.
If they would do test welds, they'd probably be less of a grinder.
And even though we say that this was a fusion process, not a welding process, it still has penetration onto the backside. So it's actually definitely melting through still. So it is when recommended by the manufacturer, it is a safe way to join the vehicle back together.
We want to try some MIG real quick.
Yeah. So we're going to change the machine over to MIG. We're going to press the program key. We're on pulse here, and like I said, 515 references the program number for material type and wire diameter inside of the case. We showed you that chart earlier. So we're just going to back up 2 clicks, and now we're on MIG mode. Press program key one more time. Let's check our material thickness. We're definitely not at 1.8.
That would have been exciting.
Yes, lots of sparks on the screen if I would have ran them at 1.8. So we're at 0.9. What's arc length look like? Give them a little bit of arc length to flatten that bead out. Ready to go.
That's welding pretty nice. Could be a little flatter bead though.
Okay. So Brett made the test weld. He said the bead was a little bit cold, a little bit tall. So I increased to 1 millimeter, and I'll adjust the arc length up by 1 to 4, from 3 to 4, and we'll see what that looks like. Thinking it'll probably help you out, level that weld off a little bit.
You can hear a difference in the sound.
That welded real nice.
Yeah, that looks great, Brett. That's a really nice silicon bronze weld there. Penetration on the backside. Where was your first one? So you'll notice that we had pretty much identical settings between the pulse and MIG mode, but what you should know is that the reason we run on pulse is because it's controlling the heat. The pulse is raising and lowering the heat that is inputted into the panel very fast, and it's controlling the heat level that's applied. So MIG mode is just one heat setting. Pulse is actually going up and down, and it's controlling the heat better. So it's giving the panel a little bit of time to cool off and the weld to solidify as you're welding. So you'll see that the penetration levels between the two are a little bit different.
Move to aluminum.
Yeah. So move on to aluminum.
One of the things I'd suggest to the viewers out there when you're working with aluminum, first, make sure that you keep your wire in a bag so you don't get a corrosion. And the same thing is, you'll notice Brett there brushing the aluminum before he welds to be able to remove the oxidization, because aluminum starts to oxidize instantly as it's exposed to the air.
Yeah, you make a good point, Tim. With the welding wire, what happens when it oxidizes and it becomes bad, it becomes brittle. It's not as flexible. So if you think about it, the OEM selected that specific welding wire to rejoin the vehicle because its strength properties and also how flexible it is when the car goes down the road and it can move and rotate. So if you put bad welding wire in your machine and you weld the vehicle, you're actually welding it with very stiff, very dirty welding wire that could be subject to cracking down the line. So you want to make sure that you have good, clean welding wire. If you weld with bad wire, you're going to notice immediately it's going to have a lot of soot. It's not going to be shiny. It's just not going to weld very nice. All right, Brett. So what do we got here? We've got, those are 2.5 millimeter plates. We're going to run with this because it's one, we're welding two stacked on each other. It's not two right against or stacked up double thickness. We have actually set the program here. We're going to run on double pulse. And what double pulse is the single pulse is what we just did on silicon bronze. It's pulsing really fast like a buzzing bee, and it's actually difficult to hear the pulses. Double pulse introduces a second layer of pulsing, and you can there is an adjustment in here how many times per second that it's going to pulse. So you'll definitely hear the difference here. If you wanted to change that, once again, you can just change it right here, pulse, double pulse, or even MIG. MIG on aluminum doesn't really produce that great of a result, so we're going to stick to the double pulse. And again, the number 422 here references the chart on the inside of the case, because this is 4043 welding wire. It's 1 millimeter. We're welding with argon shielding gas. So you would want to consult the chart on the inside of the case when selecting that program. So 1.9, we've got 3 for the arc length, and we should be ready to go.
All right.
Cover. Wow, Brett.
I
Nice
got to
job.
say, the guy that set that welder did a great job, Jeremy, because that's probably the best I've ever welded aluminum. Thank you.
No problem. That's nice, Brett. So you guys could hear that it was actually a timed pulse in the background. And the reason we do that is, once again, we're actually controlling the heat input into that panel. Because if you've welded aluminum before, it can be great and it can be bad all at the same time. And what I mean by that is, if you put too much heat, you can burn through it relatively quickly. But this machine allows you to very easily make those adjustments. And once again, we're right at the bench. We're making test welds before we walk over to the car and apply those welds.
And we can't see on the back side, I got a little over penetration, but after running that one, I could increase my travel speed a little bit.
Right.
Probably take care of that.
Yep. And Brett makes a good point here. Even if, your travel speed is maybe a little bit too fast, a little bit too slow, that is the quickest way to fix or make adjustments to your weld. But there are settings in here that can help you compensate for that. You can turn the heat up and down, or turn the arc length up and down, and you can actually make someone that is just, if you're teaching someone how to weld aluminum, you can make adjustments in that machine to try to get them over the hump and help them weld a little bit better.
I also noticed you had the crater fill setting set on this one, because I got to the end, I let off the trigger and it continued to weld, and I could tell looking through my shield it was cooling down as the weld kind of, instead of ending abruptly, it kind of like ended on a taper.
Right.
It did a nice crater fill for me.
Right. Yeah. And that is a setting. If you remember how that weld sounded, when Brett pulled the trigger, it went really high pitch, and we programmed the welder to do that. Because the heat transfer on aluminum is 3 times the rate of steel, you want to introduce more current right off the bat. to get that panel up to temp. That's why you can see here on this weld, the beginning, Brett did a nice job with the hot start on this, but if we hadn't had that hot start set properly, we would get a really tall beginning of the weld. Same thing at the end. There's a function called crater fill. Typically with aluminum, you let off the trigger and there's all that heat in the panel and it stops feeding wire. It leaves this big divot at the end. Well, the machine actually compensates for that. What it does is it reduces the heat input. It can speed up the wire that's fed into the panel to try and fill that current or that crater at the end of the weld. So there's all kinds of special parameters in here to make you a really great welder. You know, I always hear some of the technicians have been around for years and years, and they say, "Oh, I don't want to learn aluminum." You know, it's really not that big of a deal. It's not hard. It's in some respect, it's actually easier if you have the right tooling and equipment. That's what's key.
And like everything, it takes a little bit of practice.
Right.
You know, I don't run a welder every day anymore, and so it kind of helps me to do a couple of these, and I improve as I keep going.
That's right. So you want to make another one?
Should we try one in single pulse so they can hear the difference?
Yeah, we can do that. So let's push program. We're going to roll back to single pulse. As you can see, it retained the settings for the program. 422 was the 43 1 millimeter program. Push program key again. Now we're going to dial it back to, we'll go to 1.8 this time because you're a little bit hot. And then we'll give them, we like about 3 arc length there. And we'll make another weld, see what we look like.
Cover.
So I would say we were probably needed to increase the current slightly, but you definitely could tell the difference there between those two welds. We didn't hear that timed background pulse there.
Still want you to do the same one?
Yeah, we'll do another one. We'll kick the heat up a little bit. See, Brett is cleaning the aluminum oxide off the panel. Aluminum oxide, like Tim was saying, starts developing almost immediately, and it actually depends on how much humidity is in the air. So if you're in an area that's real humid, that's going to be even more important to pull that wire out of the machine when you're not using it and putting it in a bag, and also cleaning your panels before you actually weld them.
Cover.
Nice job, Brett.
Thanks. Or a little too warm, but I did slow down a little bit.
Right. So I think that would be an easy adjustment between your wire speed and a little bit of current. We could maybe bump down to 1.9, but that's why we're doing this. We're making test welds to make sure we're dialed right in. Right.
Would you like to weld next?
I think we're going to run over to the 14500. So
That's a pretty good demonstration to show how quickly you can adapt with that machine to be able to even between, as you said, each technician's different with their movement. So you have the ability to be able to make some adjustments to be able to compensate for that movement.
That's right. Yep. You can definitely make some adjustments to compensate for being too close or too far away, or too fast, too slow. You can definitely within range, but you can definitely help a technician out a little bit that's maybe a little bit irregular with their travel speed and distance.
Well, I'm gonna tell you that I'm gonna need a lot of help with my welds. So, as much adjustment as I can get to get me to a good weld. That's what I'm gonna need out of that machine.
Carl, I would be more than happy to give you a welding lesson at 11 a.m. today.
I will gladly assist.
That sounds like a recipe for disaster.
I actually love to train welding. I'll tell you what, it's great. It's great when you walk in and the facility and the technician's struggling and you leave and they're not. I mean, it's one of the things that I really enjoy. So 14500 squeeze type resistance spot welder, talking about OEM joining. Manufacturer is definitely going to recommend, in some respect, using a squeeze type resistance spot welder on steel. And the reason they're doing that, same thing we were talking about, they want to control the collision repair from a crash characteristic. And what that means is they want it to crash very similar to the way it did before it was repaired. And this machine is all about introducing the right amount of heat into the panel and making the similar size weld that was originally applied by the manufacturer. So this machine, let's talk about a couple of things that it actually does for us. You notice that this head on this welder is relatively small. And I know I've used some squeeze type resistance spot welders from several manufacturers, and always the complaint is it's so heavy. And, especially if you're reaching out in the middle of a window opening, welding a roof skin on, and you've got all that weight out in front of you, that's tough to deal with. So we just introduced this new model with this reduced weight head, compact head. It's up to 5 pounds lighter than the previous model, which makes a lot of difference when you're making,
Well, when you lift it 10 times, that becomes 50.
Right. Yeah. So if you work out, you know what that means. We're not doing triple sets of 10 here at 35 to 40 pound dumbbells is a big difference, right? So the other thing that we have here is we have the boom, and what we can do with this is we can actually raise and lower the gun, different positions, and we can actually lock it where we want it to be. And we can actually adjust forward and back, and we can lock it down where we want it to stay. So if you're welding a uniside on a car and you're making several welds across the rocker, up the B pillar, across the A pillar, you can put this thing right where you're welding. You really actually don't even need to pick it up. It's just hanging where you're using it. You can actually move this boom. You can move it right and left. Dial it right in where you need it to be. Now, this is a water-cooled machine, and what that does for you is if you make welds with this machine, you'll notice that, very quickly after you make welds, you can grab these tips. They're not hot anymore. It runs coolant right to the tips and cools it off immediately. And also, this welding head actually loosens and it rotates around. So that helps you get into different positions. If you need to maybe flip this head all the way around, you could disconnect the coolant lines and set them however you need to so they're not in the way. So there's some really nice features here. Some of the other features that the machine has is it's also auto set. What auto set is what we're actually just calibrating the machine, and then we're welding. We're not telling it how thick the material is. We're not telling it what type of material it is. And actually, we just learned this week, I was reading a procedure from a manufacturer. They require their welds to be made in auto set for some of the repair procedures. So that's a really nice feature. You don't actually have to tell it, thickness and material type. So what we also have is this is the 65 millimeter welding arm. This is the 250 millimeter welding arm. And the way that those are actually the two auto set arms that come with the machine. And the way you can tell if you're able to weld on auto set with the arm that you're using, because the machine comes with several arms, and we'll show you them here shortly. We ship with this really nice color chart. And what you can see here on this chart is this arm at the top is suitable for auto set. The one below it says not suitable for auto set. And this chart actually shows you all the configurations that you can set up with this machine to get into different areas. So we have, like I said, we have the 250 millimeter arm, 65 millimeter arm. We have several different configurations for tips. We have an offset configuration. Make sure you can, all of you in TV land can see these configurations. We have offset configurations to get into different areas. We have a couple different types of what we call roll configurations.
And some of those are really good to be used on wheelhouses and your bedsides, which are sometimes hard to reach places.
Yep. We actually, this particular tip is designed exactly for GM bedsides. So,
Which is one of my favorite, living in the Midwest.
right, yeah, you probably put a lot of bedsides on in the Midwest, right? So this one, if you've done this bedside before, you know that top rail has that lip, and if you were to go in with a normal spot welder, I'm going to say I've probably tried it in my in my career. Try to get in there with a normal spot welder, and it touches on that edge, and it actually burns and causes a hole there. Well, this tip was designed specifically for that repair that allows you to get in there and make a really nice, factory looking weld. So we really like this tip. It was designed just for that specific reason. So a couple of the other arms we have. Brett, you want to show us that 665 millimeter arm?
That's one of the largest arms in the industry, 665 millimeters, and as you can see, it's pretty light to be able to use.
So that one is really nice for rear body panels. You're trying to get into that that seam where the floor joins to the rear body panel in the back. I worked at a shop. I did, I'm telling you, I did trunk floor and rear body right back to back every day. And I really wish I had that arm when I did those repairs.
I noticed in my career at one time, I hardly ever did a rear body panel. And the next thing I knew, I did like 2 or 3 in 1 week. And I was like, what's going on? And I goes texting.
Yeah, that's right. I was going to say the same thing while we were talking about it. We think texting and driving sold a lot of rear body panels.
It did.
So
Still does.
Yeah. Well, we don't admit to it now. It's illegal.
So we've got the X arm. I don't know. Can you see it?
Yeah, so that takes you from a C to an X. So now my tips are on the opposite of where they are, and that also is going to help you get into a lot of different places that typically you couldn't get into before.
Right. The use that I can think of for that is if you needed to get the tips real close to a surface and make a weld on a flange, that allows you to get just, within millimeters of that surface and weld. Upper fender rail on a lot of cars, that would be a good place to use that. Then we have the slant arm. The slant arm, same thing, allows you to get into different areas like bedsides, wheel lips. You can install these roll tips into the ends. So wheel wells are real common for this. Also, sometimes maybe the bottom pinch weld on a rocker if you couldn't get back there. If there was something in the way, maybe like a suspension bracket or something. What we also have is here, come up so you can see. We have the single-sided attachment. This attachment does a lot of things for you. As you can see here, we've got the slide hammer on it, so it actually has a weld-on dent puller attachment. You can weld on different things like we can weld on different things like the wavy wire to make a wide dent pull. You could also weld on, we have the star-shaped dent puller ends. So those go on the end of the dent puller. Those are really nice if you don't, if you're still using like the pin dent puller. This would be absolutely great for you because you're pulling a dent and then you just twist the gun and it breaks off, and it doesn't, you don't have to grind the pins off or anything like that.
Well, you also have those studs for the wire looms that are popular. That sometimes they don't come on the replacement panel,
Right.
that you have in floor pans.
There are manufacturers that do sell their surface parts that do not have the studs for, like Tim said, not only wire looms but also for those plastic 10 millimeter nuts that hold on different brackets and things like that, so you can weld those on. And it always stinks when you break one off, not even just a new panel, you break one off, and then what do? You can weld one on and repair the panel. We can actually weld on, these are to accept a 10 millimeter bolt, so we can weld those cage nuts back on.
Remember the 80 Chevy's box side where they'd always spin off on you?
Oh yeah, yeah, yep. So you can, and then if you're, these tools aren't always for collision repair. You get into the restoration or hot rod industry. I'm sure you guys all watch those shows on, like Muscle TV and all that stuff. So the old chrome moldings that, you put the plastic clips, slide the plastic clips on, and then slide the chrome molding over it, you can weld those on,
and keep getting scars on the ends of your fingers scuffing around them.
Yeah, word for the wise. If you're going to be scuffing around those, definitely wear some gloves or something, because we've definitely got those in the ends of our fingers. So yeah, there's a lot of nice features with the welder. You can do a lot of things with it. So we'd like to show you a couple of welds. We're going to run it on auto set mode for you. So real simple, turn the machine on, and when you turn it on, you're going to see this mode right here. Make sure you guys can see can you see my screen? There you go. So when you turn it on, this is the screen you're going to see. And if we wanted to make a weld, we're going to click on easy. And then we're going to click on double-sided auto set if we're going to use the auto set attachments. So now what it's asking us to do is calibrate. And what calibrating is actually, it's going to run the tips together and it's going to zero them out. So it's going to establish the distance of 0 between them. And then later on when you're welding, that's how it determines how thick your material is, because of it knows how far they are apart.
So you're telling me I can go from a 2-panel weld to a 3-panel weld, no calibration to redo on auto set, just run.
Right. So if you think about that instance where you're actually welding, we talked about a uniside earlier. I mean, you're running across the seam on the rocker, 3 to 4 panels. You might have, you might run from 4 panels to 3 panels up the B pillar. There might be a couple spots that's only 2. You don't have to make any adjustments. You just run around and you keep welding. So that saves you a lot of time. So we're going to do the calibration now. So we're going to pull and hold the trigger. And then you see here that it says pass. And pass lets us know that we are calibrated and we are ready to weld. So here we go. Just like that. I mean, we were maybe, 5 clicks on the screen and we were ready to go.
Ready to go. I got a quick question for you. If that was to have done a bad weld or an error, how hard is it to reset it to go ahead and keep welding?
So if you make a bad weld, Brett brings up a good point. It actually is going to come up with an error, and it's going to tell you that you made a bad weld. So that's a great feature. And to expand on that a little bit, this machine actually records a welding log, which you could print out of this machine and you could save for later. Machine doesn't actually have a printer on it, but you could get the data out of it. Let me correct myself. But it's going to tell you if you made a bad weld. So that's your indication right there that, hey, I need to, maybe put another weld next to it, or hopefully that's not going to happen on the car. And it could happen, but that's your indication that that weld didn't meet the specifications for a good weld in the machine. So again, the only thing you got to do to continue welding is just click the trigger twice, and it's going to allow you to continue the weld. It's going to clear that error out.
Well, the other nice part about that logging system is if, for instance, you make a bad, it comes up and it makes a bad weld, is it preparation? Do I not have my tips configured correctly? It wants to stop you before you make a mistake. And again, with that weld logger, might take my USB stick to the welder, copy the data to the stick, and then go to your computer and be able to print that out and put that in the job file.
Right. So if we're talking about making different types of welds, say we're going to run the machine on manual mode. You can run all of the arms on manual mode. There are some specifically that you have to run on manual mode, like the X arm, the slant arm,
And the giant one.
the giant, the 665 millimeter arm. So if you wanted to access those parameters, once again, this is the home screen that you see when you turn the machine on. You're going to click easy. You're going to click double side. And you can see here now, that we actually are showing material thickness. So it wants to know what material thickness you're at. That'd be an average of the materials that you're welding together. So if it was a thick to thin, you want to be in an average. And then you click OK. Then it's going to ask you, are you welding bare ferrous metal? Are you welding ferrous plus zinc coated metal? High strength steel with the zinc coating, and then ultra high strength steel. So you would select that, click OK, and then you go right into welding. So this is where you definitely want to make a test weld. You would weld it, tear it apart, make sure you get the proper tear out according to what the manufacturer recommends, and then you would move to welding on the vehicle. So one last thing I wanted to show you on this machine is how easy it is to change an arm out. So I'm going to put this 250 millimeter arm on for you. So machine is water cooled. So if you had accidentally clicked the trigger while you had one of these hoses off, it could dispense coolant onto the floor. So just general recommendation to take turn the machine off. So disconnect the coolant lines. We're going to.
Now, I'm not going to ask how you guys know about the shooting coolant across the room.
Well, you know what they say about experience, Carl.
and you're standing there grinning ear to ear.
I think I probably know who got that experience.
All right. So machine comes with this Allen key. You loosen the bolt, and then you actually have a pin here. We're going to depress the red button on the pin, take it out, and then we're going to take the bolt out. And just like that, the arm slides off. Then we're going to slide the new arm on. Start the Allen bolt. We'll leave it loose for now. Then we'll slide the pin. Same thing, push the button in the middle, slide it into place. And then we're going to tighten the Allen bolt.
That's pretty quick.
Yeah, not bad. And then we're going to connect the coolant lines. And just like that, we are ready to weld again.
That's pretty good. So we're looking at, we have 14,500 amps at the tips,
Right.
up to 14,500 at the tips. It's 208 volt 3-phase. We do have 480, up to 480 volt units available. Squeeze pressure up over 1250 PSI. So we're well suited to be able to work on the vehicles today. And as metals change far in the future, you're looking at being automatic, taking the guesswork out of your welding.
That's right.
So are there any questions in our chat there, Carl? Because we're right at our 1 hour mark.
Wow, that was a quick hour. Let me check the chat windows. Give me just a second. I'll come right back to you.
You guys did a great job today, and I know who's going to be welding on one of my vehicles if I got a problem.
Jeremy.
I don't know that everybody's all the way woken up this morning. So a little light on chat.
Well, either that or it's almost their lunchtime, so they don't want to chat. So, and I don't see how you could have too many questions because that was a pretty comprehensive demonstration on both units. So,
Well, thank you.
thanks, guys. Why don't you take us out, Carl? And remember, at 12 noon Central, we have Danny from DEG. He's going to be on with us, and we're going to be talking about the
how to utilize the DEG.
Yes, how to utilize the DEG and be able to leverage the things that are in the DEG to be able to help you with your repair planning and estimating. So take us out, Carl.
He's got, in fact, Danny's got examples after examples of great things that they've come across in the information key pages and so on. So he's going to be doing a lot of that. So I want to thank everybody for joining us for Welding and Joining for OEM Repairs. Don't miss Danny coming up here in about an hour, and we look forward to seeing you all in just a few minutes here.
They say things are changing in the automotive industry. New technology, computers, self-driving vehicles. From where we stand, we see our future and our past. The Collision Repair Education Foundation supports educational programs, schools, and students, working to create qualified, entry-level employees ready for the career opportunities our industry provides. But we can't do this mission without you. Each year, the Foundation works to connect corporations and individuals to schools and students across this country. By being a part of our mission, you become an amplified force of leadership, reaching students, instructors, and community businesses in every corner of the industry. From where we stand, together, we see our community evolving and supporting each other. We see connections being forged in fire and fostered with trust. Connections that live long past graduation day. Connections that form the foundation of our workforce and shape the future of collision repair. Your support not only provides the much-needed resources for instructional education, but builds local communities by facilitating a sustainable workforce. A workforce trained in tradition, but equipped for the future. Learn more about how you can impact the collision repair industry yesterday, today, and tomorrow.